Hello and welcome to another episode of Breakfast with Unity. I'm your host, Max Moreau, and today we're going to be looking at optimizing our visualizer stuff that we've been playing with a bit occasionally on and off on the show. So let's just get started. We'll get started as soon as Unity gets opened. Sorry, folks, I usually have this open ahead of time. Alright, so on our last episode, we made a visualizer system. We used this one from a previous episode that's just the line visualizer, and then we added this spawning system so that it can spawn multiple game objects based on the audio that's playing. So the problem is there's actually something we can do to optimize this quite a bit. So every time that an object calls, and there could be some background caching nowadays. I haven't tested this recently, so if there's no optimization by the end of this episode, I apologize. But this should give us a lot of extra cycles to work with. So when we call audio listener GetSpectrumData, this is actually a pretty expensive call. This is expensive for a couple reasons. One of them is it has to perform a fast Fourier transform on the audio data to get the spectrum data out of it. And a fast Fourier transform is fast. It has fast in its title because the slow way is really, really slow. And there's different types of transforms that you can use that are more or less expensive. Right now we're using the least expensive one, rectangular. It works pretty well for a lot of purposes. And actually the line visual is not using that. You can actually see kind of the difference in them. It basically is different types of smoothing. But like if we switch this to rectangular, you'll see that it's a much sharper system of frequencies, and there's a little bit more bleed when you hear the clap. You see it very broad spectrum. Not that it's not very broad spectrum as it is, but you can see that it's kind of more isolated to certain spectrums when you use the fancier FFT window. So now the problem with this is expensive. On a PC, you're not going to notice it very quickly. But on mobile, you'll notice it very, very quickly how expensive this call can be. And so, what I'm going to do for our test, I'm going to actually create a new folder real quick. Create folder 83. So we're going to develop a test first so that we have something to compare against. Visualizer optimization. So we're going to... I'm going to save this scene as, and we're going to call this optimization test. Save. Actually, I'm going to call it without optimization, so we can directly compare, which will require us to make some kind of very similar scripts to actually directly compare things, but that's fine. So I'm just going to duplicate these game objects and then select them and duplicate them again, and then select them and duplicate them again until we have about 100 of them. So I'm just going to get these first 10. 1, 2, 3, 4, 5, 6, 7. All right. 105, that'll be fine. So this is not doing a whole lot of extra stuff here. I mean, it is. It's doing the fast Fourier transform, and let me actually save this scene real quick, and let's do a quick comparison to audio spawn. So if we go to our stats here and hit play, you'll see that on this one we're getting CPU thread somewhere between 5 and 10, basically, and we're getting about 200 frames per second. So if we switch over to our without optimization one here, you'll see that we, of course, have a lot more objects, so there's going to be a lot more overhead. But we've now got about a 20 milliseconds delay here, and we're down to 60 frames per second on the device here. Hold on one second, I have to let my cat out of my room. Sorry. Yeah, I know. I told her that if she wanted out of the room, she needed out earlier, but, she doesn't understand English, because she's a cat. So, alright, I'm back. So, we can see that this is a lot more expensive. And so now we can have a comparison to something that's less expensive, hopefully. So, I'm going to start working on the script. The main thing that we're going to do is What we're going to do is, instead of calling it on each object, where we grab audio listener, get spectrum data, we're going to have a master object that does this once every frame. And then we're just going to pull from that data that's on the master object, and hopefully this will optimize things quite a bit. So let's create that master object first. We're going to call this C# script. I'm going to call it Visualization Manager. And we're going to double click it. That may be a bit of a strong term for what this is going to be, but I think it's appropriate enough. And what we're going to do is very similar to what we already are doing here. I'm just going to basically copy all of this stuff here, and we'll just put an indie thing on there. And what else are we doing here? So except for we have this private float samples, we're going to make this a public float samples. And how do I want to actually do this? Yeah, let's just actually make it pretty simple. Let's do public static float samples. And so now what this does is this puts the data into samples here. And we were already doing that before, except for it was on each script. And it does this once per frame. And now we can actually just grab the sample data right out of this object rather than out of GetSpectrumData. So we're going to attach this object to somewhere. I'm just going to create a... I'm going to save this scene as... We're going to call this with optimization. Actually, I'm just going to call it optimized. And we're going to create a empty game object. We're going to call this. I'm going to put a $sign in front of it so that it shows up at the top. Visualization Manager. If it doesn't show up at the top when you put a $sign on it, you pull this menu and choose alphabetical sort. If you don't see this menu, you can turn it on in preferences under Enable Alphanumeric Sorting. I highly recommend it. It's nice. So we have a visualization manager. I'm going to put this visualization manager on here. And now we're going to need to create a new script called spawn based on visualization manager. All right, so we're now going to, this is going to be very similar to spawn based on audio. Not very similar, but there's going to be some similarities. So I'm going to open that up. Yeah, sure, save that. And we're going to open up spawn based on visualization manager. And so we're going to need, okay, so we don't need the object prefab here or spawn threshold or frequency. We need none of these things in the visualization manager. But we're going to need those things in here. All right, so we need those things. We have the game object prefab, and I'm just going to grab the update here, paste it over the update here. We don't really need the start. I'm just going to get rid of it. And instead of audio listener.getSpectrumData, we can actually just directly grab visual. All right. I want you to autocomplete, please. Visualization manager dot samples. There we go. So we've now changed this to use our new visualization manager. And so let's just save everything we got. And now what we're going to do is we're going to go to all these game objects here. And we're going to go ahead and... What are we going to do? We're going to add visualization manager to each of them. No, not visualization manager. Sorry, remove component. We're going to add spawn based on visualization manager to them. And we need the sphere object prefab. I'm just going to click this and drag it into here. That's fine. And what else do we need? Is there anything else we need to do here? No, let's get rid of the old one. Remove component. Actually, let's not remove it just yet. I want to find out. So it was 128. 0.005. So 0.005, frequency 128. And I just did that on one object, naturally. Let's do it on all of them. 0.005, 128, and remove the spawn based on audio. So now each of these has the spawn based on the visualization manager. We haven't changed Line Visualizer to use it yet, but we're going to see how our optimization goes on at this point. So if we hit play now, you can see that we now have a CPU of, 9 milliseconds rather than 20. Although it is, well, it's going up now. Why did it jump so much all of a sudden? Alright, hold on. So let's see without optimization. Save, yeah, sure. As I said, I wasn't 100% sure. So this one starts at about 15. Maybe we didn't run it long enough to see how bad it gets. So we're at 30 milliseconds now. So some of this is overhead from the objects that we're spawning, because we have quite a few of those. Maybe I shouldn't be using the spawning as an example. But let's go back to optimize and see how it starts. Definitely starts much lower. Once we start spawning stuff in, it jumps up a bit. But yeah, I think you'll find that this is considerably less taxing on everything. Why does it seem like? I guess it is probably spawning more. Here, hold on. I'm going to go without optimization, and we're going to make this a little bit less. We're going to make this so it has no spawn threshold whatsoever. And I'm going to save this. We're going to just make this a direct comparison without the spawning as an aspect. So this is without optimization, optimized. We're going to do the exact same thing. We're going to go to all these. We're going to make it so there's one. So this will never spawn a sphere in either case, or at least it shouldn't. Or incredibly rarely if it does. So so we're going to hit play now and see what we get. It's actually pretty low. So we're looking at overhead somewhere in 3 to 4.6, 5.5, somewhere in there. Expect 7 once, but that's like once. Alright, and then we'll check without optimization. We'll find out that we did not actually save that much. Find out. Let's see if that's true. Wait. Okay, so wait, were we optimized before? Okay. Oh, good. Okay, so yeah, you can see this 15 to 17 milliseconds right here. If we go back to optimized, thought we were looking at the unoptimized version, that's why I was freaking out. Yeah, definitely better. Definitely better. You can see that we were having trouble with object overhead. That's the main thing that was actually causing us. The CPU was probably all of the move forward scripts that were running simultaneously. And so yeah, so this gives us a really direct compare example. This definitely shows that this is lower cost overall than without optimization. So while we're here, since we got a couple, I'm going to go just spend the last couple minutes to create one more version of our script. I'm going to go line visualizer. I'm going to duplicate this. We're going to throw it into here. And we're going to call this line visualizer using visualization manager. Alright, and all we're going to do on here is just the same thing that we did before. Instead of doing this audio listener samples, and instead of having the sample size. Wait, do I already have that here? No, we don't need that here. Good. And we don't need everything else we need, I think. All right, and then all we do is visualization manager dot samples. Save. And I'm just going to go ahead and replace the line visualizer here. Oh, there's visualizer using visualization manager. All right. Save. All right. So I'm going to go ahead and I'm going to put the new spawn-based, line visualizer using visualization manager. And we're just going to copy these values across. This shouldn't have a FFT window here. So let's get rid of that real quick. So if you need to change the FFT window or those type of settings, those show up now on the visualization manager. Oh, this is without optimization. Okay, so I don't actually want this on here. Remove component. We're going to go to optimized, save this scene. And line visualizer, we're going to drag in the new one, copy across the values. And remove the original line visualizer here. And I'm going to break the prefab instance just so that we don't accidentally do something with that. So if you need to change the FFT window, I guess there's not a whole lot of settings that we put on the visualization manager, just the window. So if you need to change the FFT window, it's global now and it's on the visualization manager itself. So we go to line visualizer, we hit play. Hopefully the line visualizer will still kind of look the same, other than it's using the rectangular window. Yep, looks good. Cool. Anyway, I'm going to go ahead and save this scene, save the project. So thank you very much for joining us. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire, that's DRAKFYRE. And thank you very much. If you can, please support on Patreon, patreon.com/cookingwithunity. Really appreciate your support. And yeah, you guys have a great one, and I will catch you tomorrow with more Breakfast with Unity. All right. So, open link tab. Let's see if there was any questions or anything. Hello, world. Hello, Kitten Poker. Hello, Cinecat Pro. Hello, Lone Deer. Love you guys. Yeah. No problem. I'm glad that it actually optimized things. The only reason I was concerned that it might not optimize them is because I noticed that GetSpectrumData originally would return a array, and now it actually modifies an array. And so I thought maybe it was just doing a straight copy from a cached value, but no, it's not. So yay. This is the other thing that kind of tipped me off that it wasn't cached, is the fact that you can change the FFT window each time. So I didn't think that it was going to keep cached versions for each individual window. So. Late to the show, no worries, at least it's available. You can slide back in time and watch or something. I don't know. But yes, thank you guys for watching, and I will catch you guys tomorrow.